Hello, I am Mrs. O'Brien, and today's topic is division. In our textbook, this would correspond to section 6.2, division in fractions and division with remainders. The first example is from one of your homework questions out of your textbook. Describe how to get the mixed number answer to 23 divided by 5 from the whole number with remainder answer. Explain why your method makes sense by interpreting it in terms of a simple word problem. If we start by looking at it as how many groups of 5 can we make if we have 23 discs? So I've started by making 23 pink dots, and now I want to see how many groups of 5 I can make. That means there's going to be 5 dots in each group. So if I bundle them together, I will see that I have 4 groups. 1, 2, 3, 4 groups of 5 discs, but then I have these 3 individual dots remaining. What we can say is not only that we have a remainder of 3, but we can talk about how many dots that is out of the amount needed for the group. So there's 3 parts out of the 5 parts that equal a whole group. So we have 3 parts needed for a whole group. That means we have 3/5 of a group. So our end answer would be 4 and 3/5 groups. This next problem is a review of the standard algorithm with the Singapore disk model, but in this example we will end up with a remainder. So we have 143 divided by 3, which means we're going to start with 1 group of 100, 4 groups of 10, and 3 ones, because 143 has a 1 in the hundreds place, a 4 in the tens place, and a 3 in the ones place. Now because we're dividing by 3, we've made these 3 rows here, meaning our 3 different groups. And when we first look at 100, we notice that we can't put a disc in each group because we only have 1, but we have 3 groups with only 1 disc. So that means we're going to have to regroup this or unbundle the group of 100 into 10 groups of 10. And if we do that, it'll look like this. So now we have our 10 groups of 10. And as we go through, we see that we can now distribute among each of the groups. So as we distribute, we need 3, 1 for each group. And then we can take 3 more and put 1 in each group. And then 3 more, putting 1 in each group. 3 more, putting 1 in each group. And now we see we have these 2 discs remaining. And since there's 2 discs, we can't put them in the groups because there's not enough for every group, which means we're going to have to take these 2 groups of 10 and regroup them or unbundle them to become ones. So every group of 10 is going to become 10 ones. It'll look like this. So those pink circles represent the unbundling or the regrouping of the 2 groups of 10. So now what I'd like to do is the same thing I did before, which is take 3 of the circles and place them into the different groups. And I'm going to just go ahead and do that quickly so you can see what it looks like when we're done. And voila, you'll notice that we have now 1, 2, 3, 4, 5, 6, 7 in each of the groups under ones. But there's still these 2 circles or discs that we did not distribute. So these 2 circles or discs would be considered what's left over, or we call them remainders. So as you can see, we have 2 remainders, which means the remainder of 2, which is what you get after you do the standard algorithm. And if we look at our disk, we have 4 groups of 10, or 40, and 7 groups of 1. So we end up with 47 with a remainder of 2. In this problem, we're going to examine division of fractions. Jake is stranded in the middle of a desert. He has 3 quarts of water, and he figures that he will drink 2/5 of a quart each day. How many days' supply does he have? Solve the problem using only your knowledge of fractions and your knowledge of division. So I started by making a table. In 1 day, he uses 2/5 of a quart. How many days to use 3 quarts? So as I look at this, it's really the division problem 3 divided by 2/5, or the multiplication problem, how many groups of 2/5 to equal 3? This would be considered a repeated subtraction problem or a how many groups problem because we have an amount, the 3 quarts, and we are specifying the size of one group, the 2/5 of a quart, or 1 day. So we could just repeatedly subtract 2/5 over and over again until we get to the answer. We could look at this with our strips. Now if we look here, I've redone the problem showing the 3 quarts, 1, 2, 3, and then the 2/5 of a quart. So it's how many groups of 2/5 are in the 3. So how many groups of this size are in these 3 quarts? So let's just kind of look. So in each one of these blue rectangles represents a day. So if I go ahead and grab one of those, so there's 1 day, 2 days, 3 days, 4 days, 5 days, 6 days, and then each of these little pieces here would be half a day. But I could take this one right here, this piece right here, and move it up into here to make it a full rectangle. And if I did that, then I'd end up with 7 days, and this little piece down here is half of a full day. So that's where my half day comes from. So I have 7 full rectangles that would end up filled in because this chunk here can move up there, giving me my 7th day. But this one right here, I still only have half of what I need for a day. So that's why it's 7.5 days. I also represented this with division and then re-looking at the 3 the way it looks in our diagram, which is as 15/5. So not only as a fraction, but as a fraction with a common denominator as our 2/5. So this is one way we can look at a problem when it's a division problem. And again, that one piece that was missing is 1/5 of a quart, but how much of a day it is a half a day. So be very careful on those problems. Thanks for watching.